The DataVera EKG Platform covers the whole cycle of data processing. It includes data extraction and transformation, data cleaning and validation, reference objects generation, provenance tracking, reference data propagation to the target analytical systems and business applications. The result is a reference data set suitable for supporting operational business processes and generating insightful analytics. The platform can consolidate data on various business objects, such as the customers or the assets. Let's walk through the whole process. EKG Platform uses the OWL ontologies to represent the data model. We won't focus now on the technical details of ontologies. Just let us mention that they provide an unprecedented flexibility of management of the data structure and processing rules. You can assign an object to the several classes, use the same properties to describe the objects of different types, assign multiple values to each property of an object, use the language tags for the values, reuse the industry standard models, and much more. The ontologies can be created with an open source editor named Protégé. In our demo, we'll use a simple ontology containing several classes and properties representing the organizations and persons. When your ontology is ready, upload it into the EKG platform. Now you can see the classes tree, which contains the domain data model classes as well as the platform-specific classes which we will use to manage the data processing. Now we need to connect the platform to the data sources. To do this, we can create the objects representing data sources right in the platform interface using the data source class. Next step is to define the mapping rules between the domain ontology classes and data source tables, as well as between the table columns and ontology properties. We can create them manually in the platform or use the Open Metadata Integration tool to speed up the process. We choose the data source, then the database, schema and data table. The system displays a list of the columns of the selected table. Click on the Load Metadata button to proceed. Then we can see the list of the created property mapping rules. Now let's navigate to the class mapping objects. Here we have to select an ontology class which will be populated from each table. We can add SQL select conditions if needed, join several tables, and so on. Then switch to the predicate maps. Each predicate map represents the correspondence between a database column and an ontology property. We can export these semi-complete rules to Excel, complete them, and upload back to the system. We can create object mappings in the similar way to map enumerations. The mapping rules syntax is rather rich. We can join tables, combine values from several columns, use regular expressions to extract parts of the values, and many more. When we have completed the mapping rules creation, we can test them by running the script which extracts one record from the database source and check that everything is correct. Now, let's turn to the normalization functions. They can remove unnecessary symbols, split strings, etc. These rules can be implemented as the regular expressions, or we can use the EKG platform built-in functions. Using the normalization functions application class, you can define which cleaning functions shall be applied to the properties. You can apply any number of functions to single property. In this example, you can see how the normalization function cleans up and splits the comma-separated phone numbers. Validation rules or constraints are stored in the ontology according to the SHOCL specification. The property shape object specifies the target class and the severity level of violation. The constraint object defines the condition in the form of SPARQL query. In this example, we can see the constraint checking that the tax ID property consists of 12 digits. The SPARQL pattern extracts the tax ID property value from an object and checks it with a regular expression. The constraint's syntax is rather rich. We can cross-check the property values of one or different objects, search for duplicates, control dates and the numeric values, use the control ratios, and much more. In this example, the rule checks that the document has the valid issue date between 1920 and today. The next rule checks that if the customer has a local phone number starting with 77, this customer's document must be either an identity card, resident card, or birth certificate. The constraints are applied automatically when a data object is updated. The violated property values are highlighted in the EKG provider user interface. When you move the mouse over highlighted cell, you can see a tooltip containing the constraint description. Hovering mouse over URI cell displays all the violations. The Data Quality Monitor tool is displayed over the data objects list. It shows the overall percentage of data objects having any associated validation error. Hovering mouse over this tool shows some details: the total number of data records, the number of objects having at least one violation, and the violated constraints list with the number of violations of each of them. Clicking on the constraint name, you can filter list to display only the data objects which have violated this constraint. You can navigate to the Data Quality Dashboard to see more detailed metrics. The diagram in the top left part of the dashboard shows the percentage and amount of data objects having blocking and informative constraint violations. You can choose a particular data source to see this statistic only for it. We will return to this dashboard a bit later. The next data processing stage is consolidation. It consists of two steps. The first one is the duplicate search. Every business object, such as a customer, can be represented by several records in the various data sources. First, we need to bind together these records, which we call duplicates. At the second step, one reference object will be generated from every group of the data source records. To mark up duplicates, the SHOCL rules are used. SHOCL rules are similar to the constraints, but they produce new facts recorded in the database. SPARQL construct query is used in the rule body. This sample rule creates the OWL, same as relation between the persons having the same tax ID. You can see the relations inferred by the rules displayed in the data object properties. You can use these kind of rules for any data augmentation tasks. One of the examples is the new relations inference according to the graph chain relation search patterns, such as grouping affiliated persons or companies. Now, we need to create the consolidation rule, which will define the reference objects generation logic. These rules define the logic which is used when creating reference objects from the groups of data source objects. We have to define how to choose the value for the reference object properties. Use the newest property values. The system tracks every change in the data source objects and keeps the date of update of each property. Use the newest data objects. Use the data source with the highest data quality metric. Use the priority map to range the preferred data sources for each property. The property values violating the blocking level constraints are ignored at consolidation. The system acts as if these property values are not set. We have learned the following types of the rules used by the platform. Data source mapping rules allow loading data from external sources. Normalization rules automatically correct incoming data. Validation rules are marking incorrect property values. Duplicate search rules are forming the groups of data records corresponding to the same business object. Consolidation rules define the logic of the reference object's creation. All these rules are applied by default when a data object is created or updated in the platform. However, in the bulk data load mode, the rules of the last three types are skipped to speed up data loading. This affects both the initial data loading using the scripts and the data import from Excel. After populating the platform with the data using one of these ways, we have to apply rules manually, using the Apply Constraints, Apply Duplicate Search, and Refresh Reference Objects, items of the Data class menu. These operations are asynchronous and may take a long time on the large data sets. After all the rules are constructed, we have to run the initial data loading process. When it is completed, you can see the loaded objects in the classes of the data source objects. At the Reference tab of the Data Object card, we can see either a consolidation error or a reference object link. Let us switch to the Reference Object card. At the Provenance tab, we can see the origins of the property values, selected by the logic we have chosen in the consolidation rule. At the History tab, we can see when the reference object properties were changed. Let us return to the Data Quality dashboard and observe the consolidation results. The diagram at the right indicates how many data source objects were bound with the other system's data source objects, how many of them have produced reference objects or caused a consolidation error. The second row of the diagram shows the reference object distribution by the number of data source objects used to produce them. In the middle part of the dashboard, the widget shows data quality details for the properties applicable to the chosen class. At the left, you can see how many data source objects have a non-empty value of every property. The right part shows which share of the property values have successfully passed the constraints control or has the blocking and informative violations. The lower part of the dashboard shows the property statistics for the reference objects. The left diagram indicates how many reference objects have non-empty values of each property. The right part displays the share of the data source systems from which the values of each property was taken. The consolidation errors may be reviewed as the consolidation error class individuals. The good practice is that the data management personnel review this class daily to discover and correct the new errors. The data source objects can be corrected in the EKG, as well as in the data sources. In both cases, the new consolidation attempt will occur. When the initial reference data set is created, the continuous data update can be started. The platform monitors the data sources and updates the data set. The produced reference objects can be consumed by the integrated applications, by subscription or using the REST API. This allows to propagate the data changes from the trusted data sources to all the consumers, including BI tools or business applications. You can implement the Customer 360 solution using this pattern, or centralized processing of the data describing assets, documents, goods, or any other business objects. We recommend our customers to consider the data-centric architecture. The EKG platform can be used as the storage of the core data in your organization. You can implement the front-end tools for automating your business processes without creating a new database for each of them. Instead, these tools can produce and consume data from EKG. Our platform successfully handles the hundreds of millions data records under the heavy load in the real-world applications. The platform provides high throughput and offers the near real-time data processing, despite all the hundreds of rules applied to each data object. We are ready to discuss your business tasks and share our expertise in the complex IT systems integration.